Hello everyone. In last video, we have discussed the distance time graph and velocity time graph for the object at a rest condition and when the object is in uniform motion. In this video, we will discuss it for non-uniform motion. Distance time graph and velocity time graph, we will discuss it for non-uniform motion. As we have studied in uniform motion, ds divided by dt ratio means change in distance divided by change in time. That ratio or the slope of this line is the same or it remains the constant throughout the journey. Here the slope of the line is constant, or in this Vt graph the value of the velocity is constant. That we have studied. In case of a non-uniform motion, what is the basic difference is change in distance divided by change in time. The ratio, that ratio, it is not same throughout the journey. It is changing, it is varying. It may increase, it may decrease. Here that ratio was constant, but in case of non-uniform motion, it is not constant. So as an example, again we will see it. See, in uniform motion example, what we have said, that car has traveled a distance of a 20 km/h for every 1 hour, or for every 1 hour that car was traveling and additionally 20 kilometer. But in case of a non-uniform motion, if I say, see, the distances ds1, ds2, ds3, ds4, what they indicate, what this 1, 2, 3, 4 indicates, 1, 2, 3, 4, they are the time intervals. First time interval, second time interval, third time interval, fourth time interval. So for that particular time interval, the distance traveled by that car ds1, ds2, ds3, and ds4, it is changing. It is not constant. Here it was constant, but here it is changing, and here it is increasing for all the time intervals. Time interval 1, ds1, time interval 2, ds2, time interval 3, ds3, time interval 4, ds4. ds4 has a more magnitude than ds1 or ds2 or ds3. Now if I plot the graph comes like this. Here the graph was linear. It was straight line passing through the origin, but here it is not straight line. It it has a curved shape, or I will say it is a non-linear. So this is the distance time graph for non-uniform motion. Basic thing is, for non-uniform motion, the distance traveled by that car need not to be same, need not to be constant for that particular time interval. The distance is increasing. Distance traveled by that car is increasing. It may increase or it may decrease in that particular time interval. It is not constant. ds divided by dt ratio for the non-uniform motion, it is not constant, but for the uniform motion it is constant. Now if I think for the velocity time graph, we know for how we will calculate the acceleration. Acceleration is nothing but change in velocity divided by time taken. Right. Now, graphically, if I have to think, again, green color indicates the time interval and red color indicates the change in velocity. See, I will take a particular value, or I'm traveling with a car, and now when time was 0, the velocity is obvious 0. Now, when the time is 1 hour, the velocity was 5 kilometer per hour. Now, when time is 2 hours, velocity is 10 kilometer per hour. When time is 3, velocity is 15 kilometer per hour. When time is 4 hours, velocity is 20 kilometer per hour. Sir, here what we are observing is the value of dv, dv1, dv2, dv3 or dv4. It is same. It is same. And how much it is? It is 5 kilometer per hour. Suppose we are considering the velocity in kilometer per hour. So here for every interval value of dv, dv is what? dv is change in velocity. dv value is 5 kilometer per hour. But For non-uniform motion, it is not compulsory. Just for understanding purpose, here in this graph, the values what we have chosen shows that dv1, dv2, dv3, dv4, the values are same. But it is not compulsory. It is not all the time. This difference, the dv1 and dv2, they are maybe unequal. dv2, dv3, they may be unequal. dv3, dv4, they may be unequal. As here the ds1, ds2, ds3, ds4 values are increasing, so corresponding velocity dv1, dv2, dv3, dv4, they are also increasing with a magnitude of 5 kilometer per hour. So like this, for this corresponding distance time graph, if I plot the velocity, the line is passing through the origin. If I compare this graph and this graph, here the object has a constant velocity, as we can see here. This graph and this graph, they are looking the same. They look the same, but they deliver the different meaning. Here object has constant velocity, but here object has changing velocity. Here that object is accelerating, because non-uniform motion we will call it as a accelerated motion also, accelerating motion also. So here the acceleration is constant here. See, acceleration is constant here, because the what value you have chosen, 1, 5, 2, 10, 3, 15, 4, 20. Here dv1 divided by dt or dv by dt if I take, here the ratio remains constant throughout for this line. So here acceleration is constant, but for this graph, the velocity is constant. Here velocity is constant and here acceleration is constant. So togetherly we have compared the distance time graph and velocity time graph for three different cases. First case is the object at rest. Second case, uniform, when the object is in uniform motion. And the third case is when the object has non-uniform motion. Thank you.